Today we talked about the couple of questions that were at the end of your class notebook page on electrons and light, and that was looking at a mystery emission spectrum and trying to determine what's in it and what's not based on some known emission spectra for several different elements. So we'll take a look at that, go through that example. Then we'll take a look at an exercise in the Classkick app, the Bohr Model electron transition diagrams, very similar to the 4 hydrogen Bohr models that we looked at in the class notebook. But in this case, you're going to, for a random set of energy levels that your electron's going to start at and finish at, is that representative of the electron being in its ground state or its excited state? Is it transitioning by gaining, absorbing energy or losing energy? Actually drawing the diagram to model the electron transition, but also the movement of energy, whether it's leaving the atom or if it's coming into the atom. And then doing a little bit of quantitative analysis to try and determine exactly which type of light. Is it visible light? Is it in the infrared range, or would it be in the ultraviolet range? So we'll go through a couple of examples, and that should set you on your way to being able to complete that exercise. So again, if we look in the class notebook at the mystery emission spectra, the very last question, what you see here are 4 different elements, and you see their emission spectra. And so again, these are like the fingerprints for each of these elements. Now they're not in color, but what you can see is the relative positioning of their spectral lines. And again, these would be measured in hundreds of nanometers. Okay? So even though we don't have colors, even though we don't have the specific numbers and measurements, we can see approximately where we should expect these emissions to be occurring. We can see the pattern. And remember, these being like fingerprints means that if it's present in an unknown, if this element is present, you will see those spectral lines. If you don't see the spectral lines for those elements, it means that they're not there. So take a moment, pause the video, and take a look and see if you can determine what elements are present and which ones aren't. So if we take a look, we'll just start from the top and we'll work our way down. If we look at lithium, right, lithium's got 4 spectral lines, and this first one kind of close to this one right here. It seems a little bit off from it. This one, there's nothing in that region on the unknown spectrum. And this one seems to be kind of in the middle. This one's pretty close. But again, this second spectral line, where there's nothing here, that's a pretty clear indication that lithium is not present in our unknown. If we look at hydrogen, if you remember, had 4 spectral lines. And if we look, each of those spectral lines does appear to be present in the same location as the unknown. So because all of those spectral lines for that element match, we can conclude that hydrogen is present in our unknown. But notice there are other spectral lines in that unknown. So it indicates that hydrogen is not the only element present. So onward we move. Helium. Okay, this spectral line seems to match. So does this one. This one seems to match up, as does this one. And these final 2. So again, all of helium's spectral lines match up, and so we can conclude that helium is present in the unknown. Let's talk about sodium. Well, sodium's only got 2 spectral lines. That's kind of a unique spectrum in and of itself. And one of those definitely looks like a match. But again, this one is conspicuously missing from the unknown. So we could conclude that sodium is not present in the sample. Even though one of them matches, both of the characteristic spectral lines for sodium are not present, so therefore it is not present in the unknown. So now if we look at the Bohr Model electron transition diagrams exercise. Again, this is in Classkick. If you look in Teams, you will see the assignment that came through with this. And if you click on that link, it has the appropriate class code. The class code is also in the assignment information if you're going to log in with the information or with the Classkick app itself. So let me get in here. All right, and so if we take a look at the Bohr model electron transition exercise, you can see that at the top here you have, it says energy level roll, number 1, number 2. This was just a spot for us to randomly select the energy levels that our electrons would be starting at. We used to do it with dice, but I've pre-populated them in here for you. So in this first example, we're starting with an electron at level 5 going to level 1. So because it's starting at a higher energy level, that means it's in the excited state. And so you can see that excited state is listed here and it is already checked off. If it's going from a higher energy level, 5, to a lower energy level, 1, that means that it has to be giving up energy, and therefore energy will be released. And so you see that is check marked. If we scroll down, here's your Bohr model of the atom. And so if we're going to diagram the electron transition, that is always done with a straight line. So again, we started at level 5 and we go down to level 1. So you notice the arrow is starting at the 5th ring, that's n equals 5, and it's going downward to n equals 1, and the arrowhead is showing the directionality of that movement. That's important. You want to make sure that your arrow corresponds to the 2 levels, but also shows the proper direction based on whether the electron is absorbing energy or if it's releasing energy. Now, to get kind of a quantitative measurement, notice over here on the side, you can drag the ruler. And so if you click on the selector tool and you drag the ruler over and line up your 0 point with your arrow, and you'll notice it's about 1.4 centimeters. So now we drag that arrow or the ruler over to the number scale, or the color scale, excuse me, and 1.4 puts us in that top kind of lilac colored area, which is ultraviolet. Okay, so ultraviolet we know is very high energy, small wavelength. So besides the electron transition arrow, we also want to draw a wave that illustrates this energy. And because it's being released, we want to show that wave pointed in an outward direction. So you can see here how I changed the ink color to be purple. You don't have to necessarily, but the important thing is that the wave is pointed outward, indicating that the energy is being released. A bonus would be to, when you draw that wave, draw it kind of representative of the kind of wavelength you would expect. Again, ultraviolet, short wavelength. So you can see it's kind of shorter wavelengths that I have illustrated here. All right, scrolling down then. All right, the final 2 questions are simply, is the energy in the visible spectrum? Well, remember, we were up in that upper section, the ultraviolet, so we would put no. And then as far as what color, well, it's not visible light, so you wouldn't write anything in for color. And instead, you would check mark the ultraviolet box. Okay, if we look at the second example, the energy level that we're starting at is the first level, and then we're going to the 3rd level. So we're starting at a lower energy level, which means we're starting in the ground state. So we have ground state X'd off here. And because it's going from a low energy level to a higher one, that means we are absorbing energy. So we have absorbing checked off. And if we scroll down, again, we would draw our arrows starting at energy level 1, going up to 3 with the arrowhead pointing up because it's moving outward. Then we would grab the ruler, bring it over, and we see that that's about 0.9 centimeters. So we bring that over, and 0.9 puts us in the visible range and right around blue or green, bluish green, somewhere in there. So again, visible light is going to have longer wavelengths than the ultraviolet did. So if we're going to draw our wave semi-accurately, we would want to have a wider wavelength, a longer wavelength. And because the energy is being absorbed, we want to draw the wave coming inward towards the atom, as you can see here with the green wave. Scrolling down, answering the questions. Is the energy in the visible spectrum? Yes, it was. And then you would write in the color that you would estimate it to be. And again, it was somewhere in the green to blue range. So if you put blue, if you put blue-green, if you put green, any of those would be acceptable. If you said something like red or orange, though, that's not so good. That's a little far off. You should be able to make a more precise measurement, especially given the measuring tool, the ruler that you have there. If you go through the rest of the pages then, okay, slides 3 through 5 already have the numbers for the energy levels pre-populated, and you are going to answer the questions and make the drawings according to those specifications. The last 2 slides, 6 and 7, it's all you. Randomly pick numbers between 1 and 6, put them in for your 2 levels, and then answer the questions and make your diagram accordingly. You got to make sure you pick 2 different numbers, though. You can't just say the electron's going to stay home and sit in a single level. That kind of defeats the purpose. So try these out. Hit turn in Teams when you're done. That will signal me that you're ready for me to check. Speaking of checking, in Classkick in the upper right corner, there's a little hand icon. You can always click on that. That's kind of a way to flag my attention in Classkick that you need some assistance or that you want me to check something. So check that out, and I will grade this and put it in PowerSchool. If you notice you get anything less than full credit, it means something was wrong with the answers that you submitted. So check the comments in PowerSchool, log back into Classkick, and see what those comments might be. Make any corrections, message me in Teams, I'll recheck it and update your grade in PowerSchool. So thanks for taking the time to watch. See me or contact me if you have any questions, and we'll talk to you soon. Have a good night.